All right, we're going to talk about stoichiometry and information that you can get from a chemical equation. One thing a chemical equation does, if it's balanced, is it can relate quantities, meaning products to reactants, reactants to another reactants, or products to products. We're going to learn how to write mole ratios for components of a balanced chemical equation. And we're going to determine the moles of one component given moles of a different component for a balanced chemical equation. A balanced chemical equation gives you relative numbers, and you can read that as moles or molecules, of reactants and products that participate in a chemical reaction. The coefficients, that's the number that comes before the compound, of a balanced equation give you the relative numbers of molecules, and you can also say moles. So let's look at this equation. Right? If you look at it, we can tell that the equation is balanced by looking at both sides and counting the number of carbons on the reactant side and the number of carbons on the product side. Okay, here I have 2 carbons. I have 2 carbons over here. Oxygen, there's 1 here, and then 6 there, so there's a total of 7 oxygens over there. Here I have 4 oxygens plus these 3 in the water. That gives me 7 oxygens total. That was an oxygen. Okay, and if you check the hydrogens, you'd see that those were balanced as well. Okay, all of the atoms present in the reactants are accounted for in the products, meaning all of the types and the numbers of the different types of atoms on the reactant side equal those on the product side, because we have to follow the law of conservation of mass. If we were going to read a little bit more into this equation, 1 molecule of ethanol, that's what C2H5OH is. So 1 molecule of ethanol reacts with 3 molecules of oxygen to produce 2 molecules of carbon dioxide and 3 molecules of water. You can also read it using moles, and that's really what we're going to use because we really can't see a molecule or count a molecule, but we can measure a mole. So 1 mole of ethanol reacts with 3 moles of oxygen to produce 2 moles of carbon dioxide and 3 moles of water. Okay, so it's either molecules or moles. So this balanced equation, you can predict the moles of a product that a given number of moles of reactants will produce. So looking at this equation, we can see that for every 2 moles of water, I will get 2 moles of hydrogen and 1 mole of oxygen. If I double it and make it 4 moles of water, I will get 4 moles of hydrogen and 2 moles of oxygen. Now we wouldn't write the balanced equation like that, okay, but we can see that that would be true. Okay, I still have the correct mass balance, or the same type and number of atoms on my product side equaling the type and number on the reactant side. Okay, and this is just to visualize it. Okay. 2 water molecules, the atoms rearrange to form 2 hydrogen molecules and 1 oxygen molecule. If I double the number of water molecules, I'm going to double the number of hydrogen molecules that I can make and double the number of oxygen molecules that I would produce. And we can apply that concept using something called a mole ratio. Again, it's going to be factor label. Yay! Okay. And that's mole ratio, meaning that using the coefficients from a balanced chemical equation allow us to convert from moles of one substance to moles of a second substance. And we always have to convert to moles, okay, to relate substances in an equation. Let's see how this works. If we look at this balanced equation, Na2SiF6 plus sodium, 4 moles of sodium will produce silicon and 6 moles of sodium fluoride. So the question is, how many moles of NaF will be produced if 3.5 moles of sodium is reacted with excess Na2SiF6? Okay, so how do we get there? Well, just like those other problems, we have a number given in the problem. Let's start there. So we're going to write 3.50, it should be a point, moles of sodium. We're going to use factor labels to draw a time sign and a line. I want moles of sodium to get canceled, and I want to determine moles of NaF. Well, how do I relate this moles of sodium to moles of sodium fluoride? Well, for my balanced equation, for every 4 moles of sodium, I'm going to produce 6 moles of sodium fluoride. So 4 moles of sodium for every 6 moles of sodium fluoride. Okay, this is what is called the mole ratio. And we're going to determine that by the balanced chemical equation, using the coefficients in the balanced chemical equation. Okay. Moles of sodium will cancel. I'll be left with moles of sodium fluoride. Now, if you notice, I don't just write the word mole anymore. I say moles of what? Okay, because moles of sodium only cancels with moles of sodium. Right, and then I'm left with moles of sodium fluoride. So in my calculator, I'll say 3.50 times 6 divided by 4 gives me 5.25 moles of sodium fluoride. Check significant figures. I have 3 here, I have 3 here, so that should be my answer. These are exact numbers. You don't use those to determine sig figs in your answer, because those are like counting numbers. And that is a multimole relationship.